Hi, welcome back to my channel, and for today's video, we will be talking about the introduction to separable equations. Okay, so let's start first with this definition. First is a constant solution, this one here, of the differential equation given by this. We call this as equilibrium point, or some books would actually call this as stationary point, this one, if ipa-plug in natin to on this differential equation, that will be congruent to zero. That holds for all x. Your x is in the given domain of your differential equation. If we talk about this in calculus, kung napapansin nyo, meron na tayong discussion ito back in our calculus class. So, yung sa calculus lang, we consider a one single valued function. So, in calculus, we call this as critical point. Dito sa atin, tinatawag natin siyang equilibrium point because we're actually talking about the multi-valued function. This is the critical point in calculus. Why are we discussing on this one when in fact we're supposed to be talking about separable equations? Note that your separable equation is one of the tool in solving differential equations. So when we solve differential equations, that means we get the solution. So when we get the solution, we're actually bound to check if the given solution is stable or unstable. And we will have a separate discussion for that. So that's the reason why I introduced first this equilibrium point, because this will actually carry all of the techniques in differential equations. Okay, so we will now start with the separable equation. We have a differential equation that's y prime equals a function of xy. We call this as separable if your x of xy is a product of a function of x times a function of y. So basically, eto siya can be equated as p of x q of y. So this one represents a function of x and a function of y. So there is a corresponding product for that. And this corresponding product, etong sila, this one, they are all continuous on I sub x if we talk about p of x, and I sub y if we talk about p of y. What are these I sub x and I sub y? These are the corresponding interval that represents the domain of your given differential equation. Okay, so let's consider this differential equation. So your y prime is equal to p of x and q of y. And let's assume that q of y here is not zero. Basically, when we deal with solving differential equation, we assume that those that are expressed as a function of y is not zero. So because q of y is not zero, then we can rewrite this in this way. That means we divide both sides by q of y. So that is now our new equation. So again, q of y is not zero. So again, your y is in the interval I sub y. Ano kayang mangyayari dito? Okay, although we talk about q of y as a function of y, we also deal that y can be expressed as a function of x. So basically, ang mangyayari dyan, I can have yung y prime ko, pwede ko isulat as dy dx, tama? And then this is 1 over q of y of x. Tama ba? This one. And so this is actually p of x. Okay. And then if I want to integrate this, I'm gonna add this by dx, and I'm gonna add this by dx, so that one. So I add a constant c. If we substitute our u to be equal to y of x, para magagamit natin yung idea that this is a representation of a function of u. So ang mangyayari dyan, we have the integral of 1 over q of u. And your dy will now be du, and that's the integral of p of x dx plus c. So if we go back to the original y, this means that we can have the general solution in the implicit form. So this becomes the integral of dy over q of y, which is equal to the integral of p of x dx plus c. So this is now how we present the solution of the differential equation when the equation is separable form. Now again, because we have this equation as a separable differential equation, that means to say, because this one is a representation of a function with respect to x and a function with respect to y, and if you can see, yung kanina, your y can also be expressed as a function of y of x. So mangyayari dyan, we can reconstruct our differential equation and we have this of the form, this one, dx plus n of xy dy equals 0. Okay, now this one is now a representation of our differential equation. So this becomes separable. Okay, so magiging separable siya if is a product of a function of x and a function of y and also this one. So basically, this one can be transformed into p1 x q1 y dx plus p2x q2y dy equals 0. In other words, this one is written in irreducible form. So what does it mean? Ibig sabihin that this differential equation is non-factorable anymore. Nakasimplify na siya. Okay. So let's introduce another definition. So sabi dito that a point x sub 0, y sub 0, or the x naught to y naught on the xy plane is singular. So magiging singular point siya of the differential equation that your differential equation is written in the differential form or the irreducible form. This one, if yung point na yon ipa-plug in mo magiging 0 on m and n. Okay. Okay. So that will be a separate discussion. Sinali ko na lang dito because it should have been introduced in separable equations, but we will conduct a separate discussion for that. So let's focus muna on the separable equations. Okay, so let's consider this example here. Find the general solution of the equation, and your equation is given by this. So 2x times y minus 1 dx plus x squared minus 1 dy equals 0. I will just have to present to you the draft of the solution for this. So, hindi siya formal yung pagkakasulat ng solution. So, kayo nang bahala mag-formalize. So, I'll just make a draft for this. Remember that I can write this in this differential equation. I can rewrite that in this form. Tama ba? So, ibig sabihin, this one, nilipat ko sa kabila, so nagiging negative yan. And then, I divide both sides by x squared minus 1. So, dito may kakadenominator na yan. And I also divide both sides by y minus 1. Kaya dito magkakadenominator. Okay. In this case, this one here, okay, so you have 2x over x squared minus 1 and the 1 over y minus 1. They are continuous when x is not equal to plus or minus 1 and y is not equal to 1. Now, take note, however, that anong meron dito? Remember that if you have x squared minus 1, yung derivative niya is 2x. Tama ba? If you have y minus 1, derivative niya with respect to y is 1. Let us recall in our calculus before that if you have the integral of v prime of x dx over v of x, di ba ang sagot lang niyan is ln of v of x plus c. So in this case, gagawin natin yung ganyan. So this equation, again, informal lang to ha, hindi ko siya pinormal yung solution. So this becomes the ln of x squared minus 1, which is equal to the negative ln of y minus 1 plus c. So if I'm gonna transfer this to the other side, magiging positive yan. So that is we have ln of x squared minus 1 plus ln of y minus 1 equals c. And by the property of our natural logarithm, so ang mangyayari, di ba? Let's recall that ln of a plus ln of b, that's the same as ln of a times b. So, ganyan din yung mangyayari niya. So, that is ln of x squared minus 1 times y minus 1. So, na ganon. And this is equal to c. So if we want to remove this ln, that means I'll take the exponential of both sides. So this is x squared minus 1, y minus 1. This is raised to equals e raised to c. And remember, this is the same modular class lang naman. Naka-absolute value pa yan. And then, pagtatanggalin natin yan, magiging plus or minus. But because this belongs to the same modular class, so kunyari kanina, papalitan ko to ng C1, 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 C1. So this becomes, I have to let C be equal to E to the C1. So, eto lang siya. X squared minus 1, Y minus 1 equals C. So this is now the implicit general solution of your differential equation. Okay, so given with this differential equation, kanina, di ba, kung titingnan mo, we have rewritten our differential equation on this form. And because of this form, we have the restriction that x is not equal, should not be equal to the positive and negative 1, and your y should not be equal to 1 as well. So, dito pa lang, nagsasatisfy na siya on the definition of our equilibrium point. Let's go back to the equilibrium point nga. Yung definition niya kanina, anong sabi? This is a constant solution is a differential equation, a differential equation rather, is an equilibrium point kapag nagsasatisfy siya nito. So, let's double check. So, kung titingnan mo, your x equals plus or minus 1, this is a vertical line, tama? And then your y equals 1 is the equilibrium solution. Let's consider another example. 1 plus e to the y dx minus e to the 2y sine cube of x dy equals 0. And you have the initial value of y of pi over 2 equals 0. So this is an initial value problem. If you come to take a look into this differential equation, kung titingnan mo, has infinitely many constant solution. Okay. Bakit? Kasi your x equals x star, your x star, para magiging equilibrium point siya or a constant solution siya, hindi pa pala equilibrium point pa lang. Constant solution lang. Kung titingnan mo, in this case, magiging 0 yan, tama? If, ano mangyayari? This should be n pi, and your n ranges from 0 plus or minus 1 and so on. So, ang mangyayari dito, mga vertical asymptotes sila. Take a look into this. This becomes, ano mangyayari? This is dx over sine cube of x, which is equal to e to the 2y dy over 1 plus e to the y. So, bali, transfer ko to sa kabila. So, nagiging positive na siya. And then, I divide both sides by sine cube of x. So, because of that, naging denominator siya. Pero dito nga case, wala na. Also, I divide both sides by 1 plus e to the y. So, naging ganito siya. In this case, your n here is an integer. Okay. So, that means when n is an integer, your x must not be equal to n pi. Okay. So, bakit? Kasi pag nag-n pi siya, mag-undefined siya tayo dito eh. So, hindi na siya continuous yung function. So, if it's not continuous, then that's not separable. So, kailangan natin maging separable siya. So, therefore, I can take the integral of both sides. So, that's dx over sine cube x, which is equal to the integral of e to the 2y over 1 plus e to the y dy. plus C. One muna. Okay. And then I will leave this to you as exercise on continuing this solution. Okay.
Okay, that's all for today. Thank you so much for watching. If you have any questions or clarification, please let me know so that we can discuss on that. And for those who are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. Thank you and have a great day.